All right, so let's review. Find the measure of each side indicated. Round your answer to the nearest tenth. So in my case, I have it rounded to 1 decimal place. Make sure you guys read your instructions. I might ask you to round it to 2 decimal places. So here I have to solve for x, right? That side indicated. Let me label my sides first, as in hypotenuse, opposite, or adjacent. Now, I know the big side is hypotenuse. Based on this 32 degrees, 13 is the opposite, and x is the adjacent. Now, I don't have information for the hypotenuse, so I'm not going to use the hypotenuse. But I remember my acronym. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the acronym SOHCAHTOA helps me remember that. O and A, I'm using tangent. So I'm going to say tangent of 32. Now for this case, I'm only use sine, cosine, tangent because of my calculator. I only have sine, cosine, tangent. I'm not going to use the other three ratios like cosecant, secant, or cotangent. I can only use sine, cosine, or tangent. So I have the tangent is equal to 13 over x. If the x was on top, so if I had x over 13, I will say multiply both sides by 13 and you're done. But in this case, my x is at the bottom. So in this case, let me make this into a fraction here. And I'm going to flip both fractions. Okay, so what I mean with that is that I have 1 over tangent of 32. It's equal to x over 13. I just flipped both fractions because I wanted the x on top. Now let me multiply both sides by 13. So the top, let me multiply this by 13. So on the right, I have x by itself. On the left, I have 13 over tangent of 32. All right, 13 times 1, that's how I got the 13 on top. Now use a calculator. Now you guys see on EDIA right there where you guys said show your work or type your work. There's a thing that looks like a calculator. You click on it and it opens a calculator for you. Make sure you guys are using this on degrees. Let me make sure. Let me write this. Degrees. Another measurement that it uses, and usually when you open a calculator, it opens to radians. Make sure you switch it to degrees because we're working with degrees. I'm gonna mention radians pretty soon, but not this week. So degrees, that's what we're working with. Okay, so I'm gonna use my calculator. I'm gonna go 13 divided by tangent of 32. I'm gonna round my answer to 1 decimal place. 13 divided by tangent of 32 gave me 20.8. Okay, so that's it. Let's take a look at question number 7. In this case, I have the hypotenuse, so that's good. Based on the 56 degrees, x is the opposite. And then here's the adjacent. I don't have anything for the adjacent, so I'm going to be using O and H. I remember the acronym SO for sine. That means that sine of 56 is equal to x over 11. Now the x is on top, so that's good. Let me multiply both sides by 11. So on the right side, I get the x by itself. And on the left side, I'm going to go 11 times sine of 56. I'm going to round my answer to 1 decimal place. So I'm going to get 9.1. Again, my instruction said round it to the nearest tenth. So that means 1 decimal place. Remember, tenth sounds like a 10. So 10. If I said hundredth, that's 2 decimal places. Another thing we're going to be working with, let's take a look at questions 8 and 9. Because they're going to be solving for the angle. So find the measure of each angle indicated, round to the nearest tenth. Okay. See my angle, it looks like theta. Now theta is a Greek letter that means measurement. Theta looks like a 0 with a little line in between. And the way we spell that, in case you guys are interested, it's that, theta. Okay, so the two sides that I have, based on theta, I have opposite and adjacent. I don't have the hypotenuse. And I remember my acronym TOA, which means tangent is opposite of adjacent. So I'm going to write this as tangent of theta. It's equal to 3/8. Okay. Now, it would be nice if I could break my tangent and theta to leave theta by itself. And I can. I'm going to move tangent to the other side. The only thing is it doesn't move as tangent. It moves as tangent inverse of 3/8. Now, some people call it tangent inverse. Some people call it arc tangent. So on your calculator, you might have to press second or shift, depending on that. So I'm going to use, remember, use degrees. I'm going to type in tangent of 3/8, and I'm going to get 20.6. Remember, my instructions said round it to 1 decimal place, and that's what I did. I got 20.55, so when I rounded, it's 20.6. Now let's take a look at question number 9. I'm given the hypotenuse, right? Based on theta, I'm going to say 14 is the adjacent. Remember, opposite means far away, adjacent means close to. A and H, I'm going to remember my acronym CA, which means cosine is adjacent over hypotenuse. So I'm going to write cosine of theta is 14/16. To get theta by itself, I'm going to move cosine to the other side, but it moves as cosine inverse or arc cosine. I'm going to type this in using my calculator. Make sure you guys have it on degrees. I'm going to round it to 1 decimal place. I have 28.955 and on. So I know this 5 pushes this 9 over, but I'm not going to call it 28.10 because that's 28.1. So I'm not rounding up. I'm running really, really low. This 9 is at the limit, so this 9 actually ends up pushing this 8. So I'm going to say my theta is 29. Okay, let me zoom out so you guys can see what we did today.